Welcome to the Water Bearing Workshop. My name is Marty, and this is the second installment of making the backplate for the stainless steel Oona spout. So what I've done is I have redesigned the backplate. Here's a 3D print of what the part looks like, and so here's sort of what the finished part will look like. Let me reset the camera and we can take a look at what the little finicky parts are that needed to be designed and what this thing looks like. So with that, let me reset the camera and we'll go from there. Okay, so here we are. This is the original part, and here's a 3D print of the backplate that I've designed for it. It's considerably different. The biggest difference, well, the things that I was chasing, there's no raised lip around the edge here. So, this should be easier to polish. The other thing that I was chasing was a problem with a bonding lug, and I've changed that around a little bit. But I think what we need to do is we need to talk about first what are some of the constraints on the design here before I get into this. Let me sort of pull this out. This is a bronze version. I wasn't able to drill a hole in this. The other video I talked about how hard the material is to work and all that, and so I'm not able to do that. But okay, so here's a bonding wire. What this is a wire in the back of the spout. And according to, hey, there go the police. Hope they're not, where are they at? They're not after me, are they? Oh no, they drive away. Good, all right. All right, so the police aren't after me, we're good. We're gonna talk about the bonding wire, there we go. So according to electrical code, any metal object within 5 feet of the pool must be bonded to the steel reinforcing inside of the pool shell. And that's what that's there for. So when you install the spout, you sort of unscrew, in the front there's a set screw, okay? Just unscrew that. Take this little stubby temporary wire out. Put your wire in, okay, just like that. Tighten the set screw, and you're good. The part's bonded. Now, I could put the set screw for the bonding wire in the back and all, but the problem becomes then, if you ever need to remove the spout, how are you going to remove the bonding wire? And really the way these things are designed is there's some threading in the back, so if you really needed to, you could unthread the spout, right? It would come off and all that. But if there's the wires attached to the back and you can't remove it, you're not going to be able to unthread it. So I think that that's important. Also in the back of the spout is a plumbing fitting. There's this male adapter that goes in there. So you can just glue it onto PVC pipe. And that fitting is completely subsumed into the back of the spout, and that's important to me. I think if you were an installer, being able to not carve out the back of the wall and just sort of glue this spout onto a piece of pipe that's sticking on would save you a lot of time, and it's important. It's something I want to keep. So that and the no mounting holes, those are all things that are important to me, and I want to keep those in the new design. So this is the new part that I designed, and again, so this is just the back. Here's the cylinder that sits into it, so I've got some extra material here for the holes. I've got a little alignment tab. We'll talk about that. And I've got a little thickened area to do some machining, and we can add a bonding lug. And so the idea is that I make this little round piece, weld it into there, and I'm good. And I'll show you exactly what I'm thinking about there. This is just a little section of that same area, and what I would do is I'd machine a round section there, put my little piece in there, weld it, bzzz, and then flip it around, drill a little hole there for the set screw, and we're done. Well, making one of these is not that hard. It's just a piece of round stock that I milled a flat and drilled a hole crosswise. But making a bunch of them, it's kind of tough. I'm not set up for it. If I had to make 30 or 60 of these, it'd be a problem. I'd have to move from machine to machine, and I don't want to do it. It's too hard. Also, even though this tab is important, it's in the wrong place. And I didn't realize that when I laid this out on the computer. I can only weld on these three sides, and I don't want to weld across from the holes because there's a chance that I could go up too high and block the hole. So I prefer to weld on these sides, and I can't with this thing in the way. But this is important because this tab right here holds the part in place when I do the machining. What I need to do is I need to fixture these parts. It means I need to make some sort of device to hold it and clamp it in place, so I can drill and tap holes. I can mill little pieces of it. It's not like I can just set it down onto a drill press and drill holes in where I want it. It's not going to work. That doesn't work. And it needs some sort of jig or fixture to hold it, and hold it in the same place every time, so that I drill the hole exactly in that same place every time, exactly there, and I drill the little round spot there. And this tab will allow me to set this backplate in the same place every time. So that's important. But this round thing, it's hard to make, and no, I can't do it. So I need to do another design. So with that, back to the computer and off to do more design. Okay, we're back. So after some time sort of scratching my head, thinking, drinking coffee, sitting at the computer and doing all sorts of redesign work, I've come up with a different solution. And it doesn't look that different from this side, but once we flip things over, you'll see that the part is different. At any rate, and I've really focused on how I was going to make this bonding lug thing. And so I did away with this lumpy piece here and integrated into the back. You can see that the back is sort of swooped up, so in here it's thicker. And the thinking behind that was that I wanted to eliminate any potential problems I'd have on the face, because once the thickness of the wax section changes, it cools differently, and you try to keep things as even as you can and the same thickness. So I could have probably just as easily left it like that, but I did this. Anyhow, and the way this would work is I would take and mill a piece of it out, and then put in a metal part that looks something like this. Just set it on there, and then weld it, bzzz, okay. And once that's in there, I could flip it over, drill the hole for the front for the set screw, and be done. Anyhow, and I'm fairly confident I can make that. But before we talk about that, some other changes here. I moved the tab away from the bonding lug location. I changed the shape of these mounting screw bosses. They're a little longer. I got rid of this extra material here and just left a little thinner section. Again, I wanted to minimize any chances of shrinkage due to extra wax there. I think I need to, the diameter hasn't changed. I was able to get it a little thinner here, but I still think it's too round. So what I want to do next is reduce this, make it a little shorter in diameter. I need to thin this out too and see if I can even reduce this thickness, though I'm not sure about the thickness. So I've got one more redesign to do, but the good news is I think I've figured out the bonding lug problem. So in fact, I have, because I've got a stainless steel little doodad that'll fit in here and be the bonding lug. And this sort of is an interesting story in and of itself, because it's not a simple thing to make, but it's not that complicated. And I tend to do a lot of fixturing for these parts, and I think I mentioned that before. And so I've had to make a fixture for this. And so here's a block of just a hunk of steel that I had lying around that I turned into a fixture to hold the material while it's being machined. So the way this works is I take a hunk of stainless steel bar stock. I cut it to the right length. It goes in here, and these are clamps, so I need to loosen that one a little bit here. So I set it in there like that. I tighten that clamp down, and that holds this in place while it gets machined. And essentially, I machine the top part of it. There's a section there that needs to that isn't machined because the clamp holds it in place, and when it's done with the machining cycle, it looks like that. Okay, so there's the section that was held down by the clamp, and then the next step is to just flip that over, put that into the fixture again, into this other slot, and then this top gets milled off and cleaned up. And when I take it out, I'm left with this part there. So that's the way that works. And I tend to do a lot of this, I mentioned before, to hold the parts while they're being machined. I think the next thing perhaps is to maybe look at how this works. So I think we'll reset the camera and go look at how this is set up, and maybe look at the actual machining of the parts. So with that, hang tight. I'll be right back. Okay, here we are at the milling machine, or the CNC mill, or I guess more properly VMC, or vertical machining center. So essentially it's a computer controlled piece of equipment. It's a milling machine, so it's got a cutter here that rotates around. That does all the work. The cutter can be anything. I mean, it could be so here's an insert in the machine. It could be an end mill, or here's one for a drill. So you can use any type of rotating tool in the machine. And so what ends up happening is there's a column with the rotating cutter that moves up and down into whatever material you're going to cut, and the table here moves around. It's all controlled by the computer. So you essentially just write a computer program to control it, and it it makes your parts the way you want them to. I think it's just a fantastic machine. The things that you can make with this thing are just it's just cool. It's awesome. And so just like something like this, which was a sort of a test piece for the mold that we're going to make, you can't do that by hand. Having a computer-controlled machine like this allows me to do stuff like this, as well as the little bonding lugs that we're about to make. So what I've got in here is I've got a vise, and what I'm going to do is I'm going to put the fixture that I have into the vise. We'll tighten down the vise like so. We've got the fixture in there, and then we'll put the raw material. But I also need to do a lot of prep work on the machine, so before the machine cycle gets started, I'm going to make sure everything's ready and there are no disasters per se. So with that, hang tight. I'll get things reset and then we'll look at how the part gets machined. Okay, here we go. I'm going to put the stock in the fixture. Alright, that's good. Well, and there's the finished part. Okay, so I ended up redesigning this this part one more time, and this is what I got. It's you'll see it's noticeably smaller, which is one thing that I wanted to change. I wanted to make the overall diameter of the part smaller. Also wanted to thin this edge, but I didn't, and there's a reason for that. The bonding lug that needs to go in there, it's going to sit there, and there's just no room to make that all that work out. So as it stands now, and hopefully you can see that metal bonding lug just is, barely sitting underneath that ruler. And if I make this edge thinner, then there won't be room for this. And I think this is about as small as I can make it. So, granted, when I actually go to make the part, I'll mill a relief in here for that. But there's just no room. So this had to stay the thickness that it was. The other thing that I wanted to do was I wanted to make this edge thinner. And it's something that I didn't do on the new part either. And now there's a reason for that. When the part gets assembled, this goes in here, and then it gets welded on the inside. And I need that thickened edge there to weld it. Without that, it's just not going to work. And if I reduce this, the thickness of the edge, the material's not there to weld, so it had to stay. What I ended up doing, however, was I put a slight radius on that edge, so it makes the transition less abrupt, I guess. Makes it look thinner. So here it is, blam. It looks pretty thick, pretty abrupt. And then with this little radius, it maybe isn't as obtrusive. We'll see. So a bunch of constraints and compromises, and this is where it's at. And I think this part is where it needs to be. It's as far as I'm going to get it. These parts are never really done per se. Once I start making them, I notice problems, things that I could change again. And when a problem comes to light, I need to make a decision. Hey, am I going to redesign again, or can I just live with the heartache of having that problem? So, and the same will be true with this. Once we start making it, something will crop up. I'll notice something, and then a decision will have to be made. So, and that's just the way things are. Also, I think the bonding lug, which I was really worried about, is not going to be a problem. The machine, the machining of it, it worked out. I can make them. And you saw that, well, if you're astute, you saw that in the second operation, the cutter was cutting a lot of air and not really cutting this, and that's just a function of the way I had programmed it. And I think I can change that. And in fact, this edge really didn't get cut in that second operation by that corner rounding bit. It's still got these rough lines on it from the roughing. So that'll have to change. But I think I can do that. So, yeah. Well, I think we're done with that. And so this is kind of the way design works for me. I mean, you saw me, this is the first go at the part. And then I noticed some things had to change, so changed them and came up with this part. And then said, okay, there's some things I don't like about that. And then changed it again. And then, some things changed, some things didn't. Some things I couldn't. I want a bonding lug, and I want to have that part in the back, and I need some of the parts in it so I can actually work on the part and assemble it. So I don't always get what I want. And sometimes reality gets in the way, as it were, and I have to make compromises. So that's the way things are. So. Yeah, I think the design's where it needs to be at the moment, and the next step is to turn it into a mold. So we'll go to there, and let's see. Yeah. So we're going to get something similar to this, which is just a block. We'll get a block of metal with this outside surface milled on the inside, and some other little doodads and doohickeys to make the mold work. So that's what we're going to do next. So thanks for watching, and until I see you in the next video, have a good day.